Well, hi everybody, and thanks to the organisers for allowing me to share a little of my research. I first started looking at the Leafy bed as my initial research project, and I first came to the museum in the early 1970s, and a very young Alison Monbottom showed me around the collections, and wildly generated rapidly since she's managed to keep her youthful good looks. Really Johansson and Paul Taylor very kindly sponsored me for scientific research date. I think that was 2010, and we're looking back. Well, I guess like me, you find yourselves picking up new research interests as time goes on, and different questions pose themselves, or you just stumble across something of novel interest. Most of my current research can be broken down into 3 general projects, and I'd like to share a little of each with you over the next 15 minutes or so. The holocathalians are the sister group of the shark skates and rays. They're all classified together in class chondrichthyes, which is defined by cartilaginous skeleton, and primitively with spines which support the leading edge of the dorsal fin. The skin may contain tooth-like placoid scales or dermal tentacles, and males possess intermittent organs, that's to introduce sperms and female, and these organs are called claspers. Well, in modern seeds, the holocathalians are represented by 3 families. The Chimeridae, as in these images, characteristically have a short snout and a long whiplash tail, leading to their common name, ratfishes, or sometimes known as rabbitfishes. And notice the prominent dorsal fin spine on the leading edge of the dorsal fin. Those of the Chimeridae, in contrast, have a much more sharp-like heterocircle tail, which basically means to say that the lobe of the tail below the main axis is larger. And the name Calorinchus means beautiful snout, and it speaks of the soft, plough-like structure you can see here. They're commonly known as a consequence as elephant fishes or plough-nosed chimeras. And that snout is packed with an array of electrosensory organs for detecting prey just beneath the surface of the substrate. The final living family is the Rhino Chimeridae, also referred to as the ghost fishes or spook fishes, and in this case, look, the snout is considerably elongated. There's a prominent anal fin, and the tail is generally hypercircle. In other words, the lobe that's on the lower side is better developed than the upper. Well, in the fossil record, holocathalians are mostly represented by isolated tooth plates or isolated dorsal fin spines. The tooth plates may have either a crushing or a sectorial, that's cutting, action, or sometimes a combination of both. And they possess a characteristic tissue which comprises pillars of a material known as whiplokin. That's the little spots you can see of the image on the left. Dorsal fin spines are typically ornamented with barbs or denticles along the posterior border of the distal part of the spine, and they may have tubercles on the lateral spine walls, as an example you can see here. Well, since holocathalians possess a high organic, low inorganic cartilaginous skeleton, whole-body specimens are very rare, except in conservation shown, such as the Plattenkalk lithographic limestones of the Solnhafen area in Germany. And I've recently been working with David Ward, who you'll see in a few moments, Evgeny Popov from Russia, and Bruce and Renee Lauer from Chicago, investigating some beautifully preserved holomorphic specimens, that's complete specimens, from the Upper Jurassic of Germany, and held in the collections of the Lauer Foundation. 3 taxa are represented, and I'd like to just show you them and some of the differences between them. The smallest is Elasmobectes avitus, first described in the 1860s. There's a fairly short snout and a prominent dorsal fin spine, and you can clearly see the ring-like centre of the vertebral column and representations of the supports for the fin structures. There are a later one. Magic. So, these are the centre going down the middle there, and we've got supports for the fins up at the top. One rather surprising feature is this tail. It's called a digicircle tail, and it's rather unusual structure for polycethalians because the two lobes are basically the same size, or near enough, either side of the vertebral column. This specimen here, and you can see that because of these long-haired pelvic claspers. So these very long things here. They're used to insert sperm, as I said, into the female reproductive tract. I'm sorry to introduce sex drugs and rocking the world into these proceedings, but there we go. And there's a closely associated large cartilage called the pre-pelvic tenacula. That's this sort of almost trapezoid shaped thing here. And you can just make out, just there, some barbed denticles along the leading edge of the structure. Normally it's kept in a pocket of skin, and this tenaculum is protruded when it's needed, and the denticles stimulate the female as a mating aid. Males also possess head claspers, which you can see outlined there. There's a long cartilage and then a thing that you can't see the detail of there. Here it is in a bit more detail. And you can see that there's a cluster of denticles, and these oppose a series of denticles on the surface of the sac, and together they grip the female during mating. Well, representations of the soft parts is quite common in specimens from Solnhofen, depending a little bit on the coarsely recrystallized calcites in adjacent cartilages. Here, for example, in that area encircled by red, is what appears to be the spinal valve of the small intestine. And this arrangement slows down food transit and increases the absorptive surface area of the intestine wall whilst conserving intestinal volume. In this case, the tooth plates are sectorial or cutting in action. That's where they are, and this is what they look like. You can just see the small units of whiplock in these little spots that you can see in lines there. And their arrangement has allowed us to place the species in the genus Elasmodectes. You can also see a series of rings, these here. These are parts of the sensory canal system in the skin overlying the toothpaste system, which now collapsed onto the toothpaste themselves. Now, beautiful as these specimens are, exposed in lateral view, often the taxonomically most important and informative parts of the skeleton aren't visible, especially the dentition. You can only see the side view of the toothpaste here, whereas it's the occlusal view that's most informative. But fortunately, the scattered remains of two specimens of Elasmodectes have recently been discovered from excavations at Nussbaum by the Stadtwerke Museum in Stuttgart. These deposits are slightly older than those at Solnhofen, and the toothpaste have been exposed in occlusal view, permitting a reconstruction of the dentition. As you can see there, this is Elasmodectes swimming towards you with its mouth open and full of intent. The next taxon, we go from the smallest to the largest of the Solnhofen polycethalians, and at around 1.5 meters long, several differences are immediately clear comparing Ischia spongicetti with Elasmodectes. Firstly, look, the tail is strongly heterocircular, and there's a clear anal fin. So there's the anal fin, and then rearrangement to the tail. And reconstruction. Okay. The snout protrudes from the front of the robust skull cartilages and was entirely composed of soft tissues. So the margin of the skull is coming down there like that, toothpicks there, and this is the soft part of the snout sitting out in front. It's not collapsed, which it does mostly in specimens of this type, and the complex branching network of sensory canals, you can see there, running over its surface, allows us to reconstruct the pathway of those canals again, which is taxonomically important. And the lower angle slide here, using photography, reveals a plough-shaped snout, clearly outlining this animal with the colouring kit which I showed you earlier. In some places, it's possible to make out traces of the myotomic musculature. Now that's these faint lines here. We can see divisions between the muscles and then the individual muscle fibers between them. If you ever held a goldfish or something similar up to the line, you would have noticed a series of zigzag muscle blocks which make up the body wall. This is an ingenious arrangement which permits smoothing out of the bending nature of the body when side-to-side movements are required. Isolated toothpaste of issue 2030 are available in older collections of Tübingen and Stuttgart, again permitting the reconstruction of the dentition. Notice that in these cases, the toothpicks are much more robust than in the case of the plasmodectomies, and the whip again is arranged in a series of large crushing triangles, like these things here, on the occlusal surfaces of the plates. Well, the final member of the form is distinctive. This is only the second known specimen, and by far the most complete, of Chimeropsis paradoxa. It's somewhat intermediate in length between the two that we've seen earlier, and notice the robust toothplate, which we've got in that position there, although no details are visible for their crushing surfaces. But unlike the other two genera, Chimeropsis doesn't have naked skin, but belongs to a group of Myricanthidae which possesses several tuberculated plates in the head region and large numbers of stellate scales, such as you can see here. The field of view is about 2 millimeters in this instance. Now, you see that big white patch in the middle of the body there? That's a representation of the musculature. And you can see the individual muscle fibers there in close-up, about 2 millimeters both field. Well, these specimens have a lot of potential for characterizing the three taxa, which clearly differ in terms of their snout structure, their fin type, their dentition, and several other features. Just got the dorsal fin spines adjacent to each other, and you can see they're clearly distinguishable on the basis of size, the amount of curvature, and the presence or absence of the tubercles. Living chimeroids lay eggs in pairs, as in this absolutely unique example from the fossil record actually, but from Solomon. The cases themselves are leathery, collagen-rich, multi-layered, and made of protein, and this gives them a very low preservation potential, so that much taphonomic loss occurs through decomposition, bioerosion, deposition in unsuitable sedimentary fascies, etc. And this means that chimeroid cases are very rare indeed in marine ichnoforms. Well, these plankton carp cases are flattened with an ovoid central trunk, which tapers posteriorly to an elongated pedicle or tail. And the spindle-shaped central cavity houses the embryo, and then the lateral margins are extended to form a membrane, as you can see here, which is commonly augmented and strengthened by rib-like corrugations or costume. Movements of the embryo stimulate the water entry and through flow via a system of very fine pores, enabling efficient gaseous exchange. Cases belong to the three extant families can be distinguished on the basis of shape, which you can see there on the top right. The fusiform central cavity of the fossil specimen is elongate, extends into a large, long, slender pedicle, and the top part is also quite slender. And all these factors together suggest, together with size, that these egg cases probably belong to a carinid, and making Ischios vegetatis is the likely producer. So that's the Jurassic chimeroids. Now move on to late Triassic chondrichthyan or cartilaginous fish faunas, and one of my heroes is the leisure Victorian geologist Charles Moore. Moore married well, resided in Bath, and elucidated much of local and Somerset geology. He was a great collector, especially in late Triassic rocks, and was the first to identify the presence of the region in the UK, and most famously collected a huge haul of vertebrate fossils from fissure infill deposits of a locality in the Mendes called Holwell. He was innovative in his processing techniques, and he picked sieve residues which yielded many thousands of microvertebrates, including the celebrated collection of Pteromaea teeth. Here he is in the company of Murchison, there, and Livingstone, there, leading the field trip to the Holwell Quarry in 1864. Well, much of Moore's material was left undescribed, and I've spent many years trying to redress that omission, most recently describing a lepidosaur fauna with another scientific associate here, David Whiteside. The Holwell collection used several new lepidosaur taxa, plus formal elements known from other localities, helping us to link various fisher types from the late Triassic and early Jurassic of the UK. And further collecting from local localities has yielded further mammalian and lepidosaur remains from other temporary exposures. More also collected from rocks exposed to the foundations of a house at the village of Rushton near Taunton in Somerset. The house no longer exists, but it was at or adjacent to the site of a new park and ride facility, so in Taunton. The only component of the fauna described properly is the xenocat shark described by Woodward, now appropriately known as Murodontus muria. This has proved to be an important fossil for correlation of non-marine carmine sequences, and the new temporary exposures in the North Curry sandstone of the area are being worked by myself, Mike Benton and Alistair Russell. And an important part of the work has been making an initial appraisal of Moore's collection from the area so that our own material can be compared to it. The fauna includes the teeth of the hydrodont, which has a complex and very confusing nomenclatural history, but there are also teeth of the little-known palliative Cocorhinus, originally described by Murchison and Strickland from the Arden Sandstone Formation of Warwickshire. And these rather strange structures were originally described from the Kuiper of Woodsworth as teeth by Winkler from the Tyler's Museum in Harlow. They're not actually teeth at all, but the cephalic spines, albeit very weird, of male hydrodont sharks. These are more common sorts of appearances, though cephalic spines also from the same deposit in the Russian fauna. The Arden Sandstone of Warwickshire has also yielded some enigmatic teeth originally assigned to the genus Bibodus. Recent examination of the material, together with Sasha Ivanov from St. Petersburg and Marco Richter from here, has yielded some surprising results. Specimens from the NHN collections, and notice that on the crown there are three quite widely spaced cusps. Micro-CT scanning of the specimens has yielded a wealth of greater detail, and when compared to Paleozoic teeth of sharks allied to the Phelodonts, the Warwickshire material shares numerous characters with genera that have been placed into the family of Gelodontidae. So revision of the group has led to the order Gelodontiformes to embrace a lineage currently ranging from the Flammarian to Cocorhoidus, the genus of the naming from Warwickshire, with all sorts of varieties in between. So that the English material is the last member in the late Triassic. And then just finally, for something completely different. I've got a strong interest in the history of geology, particularly the historical usage of geological materials in unexpected cultural situations, especially in folklore and medicine. And most recently, I've been looking at the amuletic and prophylactic uses of rocks and minerals and fossils, and I'd like to illustrate that with reference to these things, Freisketta or convulsion chains. These are, as you can see, rosary-like polyamuletic chains, particularly popular in the Austro-Bavarian region in the 17th through to the 19th century. The idea of the chains was to offer protection for children against a whole host of childhood conditions collectively known as frays. Rather defined from the perspective of present-day medicine, this condition embraced all manner of childhood convulsions, spasms, fevers, cramps, fits, and seizures. It's difficult to be precise, but several conditions probably were incorporated here, but particularly obvious is childhood onset epilepsy. The strains contain all sorts of items believed in various ways to protect the child, from religious medallions and reliquaries to examples of medicinal folklore. The surprising thing is that fossil shark teeth make occasional appearances on these chains. Commonly known historically as glossy petri or tonguestones, their shape supposedly evoked the forked tongue of a snake. And this association by sympathetic magic suggests that glossopetri would be protected against all sorts of poisons, because snakes make poisons, and because of the similarity of the snake's tongue, that it should therefore be effective against poison. So, effective against poison from bites of venomous creatures, but also poisons associated with disease. Indeed, there's a long history of shark teeth being mounted as pendants and worn for protection. In medieval and Renaissance times, special items of tableware had shark's teeth hanging from them, fossilized shark's teeth, this is, ready to dip into the wine in order to assay it for the presence of poison. Here we are, this is a 16th century example. Only 3 of these things remain. The theory went that if you dipped it into the wine and took it out and the tooth was discoloured, it proved that the drink had been tampered with in some way. So it best to avoid it. Well, during the 16th to 18th century, the Zoa stones, which were credited to a host of therapeutic and prophylactic powers, especially against poisoning, they had concretions of undigested material formed in the gut of a variety of mammals, but especially the Zoa goat from India. High market demand in the late 17th century meant that supply chains from India to Europe via Lisbon found itself under considerable pressure. The Jesuit lay brother, who had moved to Goa to fulfill his calling, came to the rescue by inventing an artificial substitute for the stones, and his secret recipe, now lost in the Vatican archives, involved mixing a wide range of ingredients together, including pulverized fossil shark's teeth. The end result was fashioned into a therapeutic ball covered in gold leaf to add to its allure and sense of authenticity. And these gold stones were credited with identical powers and efficacy as the beleaguered Zoa and were kept in specially built silver and gold cages, as you can see here. So the presence of fossil shark's teeth on the combustion chain suggests they were being employed as protective agents against all manner of poison. Just finally, it was commonly believed that sudden frights experienced by a pregnant or breastfeeding mother, or even directly by a newborn child, might give rise to the development of deformities, producing monstrous, strange birthmarks, as well as the child developing convulsions, fevers, chills, and occasionally suffocation. So in order to neutralize the effects of these pre- and postpartum shocks, special stones called Schreckstein, or fright stones, were worn as amulets. And here's a range of such stones from the Freisketter which I've been studying. They're all pendant-shaped and placed in silver mounts. Many of them are faceted. The malachite hearts are particularly auspicious, and they were believed to give special protection against epilepsy and the effects of the evil eye. Sometimes they were referred to as midwife stones because they were also believed to help with childbirth. A wide range of banded agates, chalcedony, and different types of jasper are included in the variety of Schreckstein you can see here. Pendants of fossil coral were sometimes referred to as Kratzenstein or scratching stones, and they were believed to afford protection against rashes and skin complaints, especially scabies. The spider-like pattern of the septal walls probably account for this association. But the belemnites and Neolithic arrowheads often appear in this context as well, and they each have a long pedigree as Donnerstein or thunderstones. It was believed they fell to earth from the heavens during thunderstorms, and since lightning supposedly doesn't strike twice in the same place, if you carry a specimen with you in your pocket all times, you will be safe from any lightning strike. The final archaeological component on such chains are Gishulu, or gout stones. Gish was once again associated with epilepsy, and these bead-like balls were usually made of amber, banded agate, sometimes carnelian as well, as you can see in these 2 examples. So the combustion chains were either worn over the shoulder by the young child or hung on the bedstead so as to protect the sleeping infant through the night against all the things that might assail it. Thank you.
Thank you very much, Chris, for giving an insight into your. No, I mean, it's a really interesting set of research, particularly stuff into the right direction. It's really good. Oh, we've got time for a quick question if anyone has anything. Yeah, what back? Was that Paul? Alan, sorry, Alan, I can't think now.
I presume you realise there's art and photography at the museum. It's not really researched much. The only research I've seen on that is with this suite of is, of course, the Sir Hanslow Pharmacopoeia, there's 2 drawers in the collection that were part of Jesse Street's. There was some research done on the chemical natures and those things, but there are some bizarre objects and stones, significant oils in that.
Yeah.
Which, you know, you wonder if it's part of that chemical, part of the chemistry say and the pharmacopoeia, he's handing out these things to be counted.
Yeah. Yeah, in fact, there are 4 drawers surviving. One of them is on display in the King's Room in the British Library at the moment, which is the mineral drawer.
Yeah.
And it does have weird things like balanicidrous spines, belemnites, and all sorts of things. And they were part of Sir Hans Sloane's stock in trade. So, yes, one presumes he was using them on a daily basis.
Okay, good.
Yeah.
That's nice.
Serena.
Great talk, Chris, and I have a couple of questions. First of all, the first specimens that you showed, are the Lauers still collecting?
Yes, they are. Yes, they're slowly adding to their collections, yes.
Fantastic. And do they allow anybody to come look at their specimens, or?
Yes, it's publicly available, but with sort of, I can't say restrictions, I don't mean restrictions. Sorry?
By appointment?
Yeah, by appointment, that's right, yeah.
Okay. The final question is whether you ever see any embryonic polycapillins in the locality or associated with those 8 cases you showed?
Yeah, not associated with the 8 cases. As far as I'm aware, there's only been one Calorinchus embryo, newly hatched embryo, been described, and that was in Frick Hinger's volumes of the Solomhof, the 2 Solomhof books.
Brilliant. Thank you very much, Chris.